Deep in the farthest corners of the universe, scientists have made an astonishing discovery thanks to the James Webb Space Telescope. This advanced telescope has detected a structure that is nearly as old as the universe itself, dating back about 13.8 billion years. The discovery has amazed researchers worldwide, raising exciting questions about how the universe began and giving us a rare glimpse into its earliest days. One fascinating part of this mystery lies in a star known as HD 140283, often called the Methusela star because of its incredible age. Located around 200 light-years away in the constellation of Libra, this star is estimated to be about 14 billion years old, nearly the same age as the universe. At first, scientists thought it was even older than the universe itself, which caused great debate. Although newer calculations have brought its age closer to 14.46 billion years, it still challenges our understanding of cosmic time. Determining the age of a star is no simple task. Astronomers study its brightness, color, and rotation speed to estimate how long it has existed. Over time, stars slow their rotation, lose magnetic activity, and show changes in their light. By comparing these clues with models of how stars evolve, scientists can estimate their ages. For example, our Sun is about 4.6 billion years old, but Methusela's star has existed far longer, with very few heavy elements in its makeup. This suggests it formed during the early days of the universe, before heavier elements became common. While stars like Methusela capture attention, the James Webb Space Telescope, JWST, has gone even further. Since it began operations in 2022, JWST has shocked astronomers by spotting galaxies from a universe's infancy. Galaxies larger and brighter than scientists expected to exist so soon after the Big Bang. These discoveries are forcing researchers to re-examine long-standing theories about how galaxies form and evolve. Some even wonder whether these galaxies truly exist as we think, or if we may need to adjust our models of the universe. JWST was built to go beyond the Hubble Space Telescope, revealing secrets hidden in faint light from billions of years ago. Its mission is not just to confirm what we think we know, but to challenge those ideas. By capturing light from galaxies formed shortly after the Big Bang, it has given scientists the ability to study the universe's baby pictures, providing evidence that may rewrite parts of cosmic history. The Big Bang theory, first proposed in the 1920s, remains the most widely accepted explanation for how the universe began. According to this idea, the universe started from an unimaginably hot and dense state, then expanded rapidly. In the earliest moments, forces like gravity, electromagnetism, and nuclear interactions separated, shaping the physics we know today. Matter and antimatter formed, but most annihilated each other, leaving just enough matter to create stars, planets, and galaxies. This expansion continued, cooling the universe and allowing atoms to form, leading eventually to galaxies and stars. The structure era of the universe, which began billions of years ago, is what gave us the cosmic web of stars and galaxies we observe today. Unlike an explosion in one place, the Big Bang didn't happen at a single point. It happened everywhere, all at once, expanding space itself. The James Webb Space Telescope is now helping us piece together these early moments with unprecedented clarity. By studying ancient galaxies, stars like Methusela, and strange cosmic structures, it allows scientists to look deeper into our origins than ever before. These discoveries not only reshape our understanding of the universe but also remind us how much mystery still surrounds the question of where everything truly began. The idea of the Big Bang often makes people think of a giant explosion, but it was not an explosion in the usual sense. While it is the most widely accepted explanation for how the universe began, it also has its challenges. One of the biggest is the horizon problem, which questions why distant regions of the universe look so similar even though they should never have been able to exchange information or energy because of how far apart they are. Another issue is the flatness problem, which comes from Einstein's equations. These suggest that space on large scales should curve depending on its density, yet the universe appears to be very flat. To solve these puzzles, scientists developed the idea of cosmic inflation. This theory says that very early on, the universe expanded incredibly fast, smoothing out differences and setting the stage for the galaxies and stars we see today. After the Big Bang came the cosmic dark ages, a time when the universe was filled with neutral hydrogen gas that blocked light. During this period, no light could travel freely across space, making it impossible to see what was happening. It wasn't until about 1 billion years later that the first stars and galaxies formed, releasing energy that reionized hydrogen and allowed light to escape across the cosmos. This moment lifted the cosmic fog and made it possible for light to eventually reach us. Even so, these dark ages remain a barrier that prevents us from directly observing the earliest moments of creation. This mystery led scientists like Stephen Hawking to ask deeper questions about what came before the Big Bang, and whether it even makes sense to think of a before. Hawking, along with James Hartle, proposed the no-boundary idea in 1983. They imagined the universe like the bottom of a shuttlecock, the rounded point representing a beginning that is not sharp or sudden but smooth, without a true starting boundary. According to this view, time itself may not have existed in the earliest stages. Instead, time as we know it slowly emerged as the universe expanded and entropy, or disorder, increased. Before that, there may have only been pure space, without a sense of time. This no-boundary proposal also introduced the concept of the wave function of the universe, a way of describing all possible states of the universe, past, present, and future, together. It is a radical idea because it removes the need to ask what happened before the Big Bang. In this framework, before simply doesn't exist. Hawking compared this to the South Pole. You can go south until you reach the pole, but there is no further south. Likewise, you can trace time backward until the Big Bang, but there is no before. Some scientists have expanded on these ideas. They suggest that if the universe had no boundary, then maybe a mirrored version of our universe could exist on the other side of the Big Bang, where time runs backward. Others think the universe might not have had a single beginning at all, but instead follows a cycle, expanding, contracting, and then expanding again in endless Big Bangs. These theories challenge our traditional view of a single moment of creation and instead suggest a more complex, perhaps infinite, cosmic story. The James Webb Space Telescope's detection of structures as old as 13.8 billion years has added even more weight to these discussions. By allowing us to look farther into the past than ever before, it raises new questions about whether our understanding of the Big Bang is complete, or whether we are only beginning to uncover a much bigger cosmic mystery. The Big Bang theory tells us that the universe began as a tiny, dense point that expanded at an unimaginable speed and has been stretching out for 13.8 billion years, forming the cosmos we see today. For decades, this idea has been the foundation of modern cosmology. But recent discoveries made by the James Webb Space Telescope, JWST, have shaken that foundation, leaving many scientists questioning what we really know about the origins of the universe. Astronomer Alison Kirkpatrick from the University of Kansas admitted that the telescope's latest images have left her, and many others in the field, unsettled. The JWST revealed galaxies that are smooth, mature, and far more numerous than expected, something that doesn't align with the Big Bang's predictions. According to the theory, distant galaxies moving away from us should appear smaller, yet the telescope shows even massive galaxies that look similar in size to nearby ones. This unexpected finding challenges the very concept of an expanding universe. Researchers like Eric Lerner and Ricardo Scarpa, who had already questioned the expansion model, believe these results support their earlier claims of a non-expanding universe. They point to discrepancies in redshift data, some appearing 2 to 3 times greater than predicted, as evidence that something doesn't add up. Instead of confirming old theories, the JWST has forced scientists to confront new uncertainties. One of the most surprising revelations is the abundance of well-structured spiral galaxies. The Big Bang model suggested the early universe would be chaotic, filled with young galaxies colliding and merging. Instead, JWST images show galaxies that look calm and organized, similar to the ones we see today. This discovery has cast doubt on the idea that mergers were the main drivers of galaxy formation. The telescope has also found galaxies that appear to be at least 1 billion years old, even though it's supposedly observing them just 400 to 500 million years after the Big Bang. This timeline doesn't match up. If the Big Bang happened as we think, those galaxies shouldn't exist so soon. Adding to the mystery, Scientists expected JWST to eventually see fewer galaxies the deeper it looked into space, pointing to a dark age after the Big Bang. Instead, they found massive galaxies forming much earlier than predicted, some as large as the Milky Way. Despite these challenges, supporters of the Big Bang argue the theory still holds strong. Its core evidence remains: the observation of higher redshifts in distant galaxies, the discovery of the cosmic microwave background radiation, and the abundance of light elements like hydrogen and helium. These pillars form the backbone of the current standard cosmological model, known as lambda-CDM. Still, JWST has highlighted some troubling inconsistencies. Predictions about the amounts of helium and lithium don't match observations, and the existence of giant cosmic structures seems impossible within the time since the supposed Big Bang. Yet astronomers remind us that the telescope's mission was never just to confirm existing ideas but to challenge them, and to reveal the universe in ways we've never seen before. Far from ending the Big Bang theory, these findings have opened the door to deeper questions. Is the universe really expanding, or is there another explanation? Were galaxies born faster and earlier than we ever thought possible? Or do we need a completely new model of the cosmos? The James Webb Space Telescope hasn't given us final answers, but it has proven one thing: our universe is far more mysterious than we ever imagined.